So just one setup slide here really quickly is we're kind of framing this as reimagining how to automate configuration management. So I referenced old tools that literally take CLI and just blast it out to devices, highly unreliable. I was referring to the complexity in the network, meaning how do I code one common thing when each platform requires the syntax a little bit different. Maybe there's different port mappings, so you have that complexity. When you move to scripting, simple scripts can be easy to get started, but as you're going to see, especially as we touch on the Ansible piece, as you start trying to do complex things with scripts, the scripts get complex, and you have to incorporate Jinja 2 templates and other data modeling capabilities, and you're really ultimately you're probably going to have to edit some Python, and you're pretty quickly slipping into that developer world. And it's an uncomfortable space for a lot of networking engineers. And then NetOps is delayed due to the manual troubleshooting process. So those things add up to that. So with Gluware, we're going to show you in some detail how we do declarative provisioning, how we're able to accomplish abstraction, how we are closed loop in terms of that integrated verification. And we're going to be showing this through our technology, again, called config modeling. It's our approach to config management. It is dynamically data modeling or leveraging a data model to accomplish it. And then a very new capability we introduced in our last release, where we've refined it in our latest release, called Intelligent Model Discovery, which is able to read off a network device and create those data models on the fly. So I'm sure one of the questions is, well, how do you build the data models? We're going to show you just that.
So going to talk about config modeling. So what is the purpose of config modeling? Mike talked about onboarding, brownfield. So what are networking engineers doing best? I mean, this is what they're trained. I mean, Mike is on the rogue side, he's a CCIE, and this is what he's done, building all that expertise. This is learning your protocols, learning your CLI. So we want to empower the network engineers to continue using this knowledge. So config modeling is all about allowing network engineers to onboard their existing CLI, not have to redeploy everything. It's already out there on all the vendors that they're using on the network. So config modeling is breaking this big monolithic configuration that you have when you do the show run of a box and turn it into those snippets that makes those network functions. My routing, all my encryptions to the one, my quas, my security, etc. And once you have those snippets and build all these network features, I mean, how do you render this to the nodes? I mean, delivery is extremely, we also call this rendering. This is extremely critical to the success of a deployment, because you can have all this theoretical CLI. If you don't have a reliable and mechanism to deliver that CLI, it's going to be, you're going to have problems. So I promise I won't try to kill you with too many slides. So on the left, you have your network model. You have your CLI, all the snippets that you have, and you want to send this to the node. So we have a Gluware delivery engine, and this particular engine will basically deliver the CLI to the node using SSH to interact with the node. Something to note is that we also support out-of-band, something pretty important. Let's say you broke your box. Gluware is extremely good. After this demonstration, you'll see Gluware is pretty good at fixing things. So out-of-band sometimes can come to the rescue because you've lost your box. You need to fix it. Okay. So this is the overall model. Use SSH to deliver configuration. But guess what? This is not good enough. This is not good enough because you don't want to try to push the config over and over and over. You would want to assess already what's in the box. And you want to do this because, like Mike was mentioning earlier, you want a declarative approach. You don't want to figure out what is on the box already. I mean, this is something that was very important for Merck when they were deploying quads. They have tons of boxes where they wanted to deploy quads. You have no idea what's the state of the box. And you know what? It doesn't matter. Because you want to be able to declare, this is what I want as an end result, and you want the engine to figure out, oh, okay, I'm going to have to add this, I'm going to have to move this, shift this, and most importantly, delete this. deleting is extremely difficult because it's not in the model. If it's not in the model, it shouldn't stay in the box, right? So that's
Quick question.
Yes.
So this is configuration based though.
Correct.
So if I say this is my reference architecture for what a QoS policy looks like, but that's not the network behavior that I want, can you model behavior and state even with like ephemeral information like this? Do you see what I mean?
Yes.
Because then you go back and you say, I have this list of models from which to choose in order to elicit that specific network behavior. Is that where we're going maybe?
This is exactly what one of our customers that was deploying Office 365 was going through. The fact that they were able to send this initial cross configuration on the network, they thought, this is what they did in their lab, they thought that it was a successful model. And then they realized after time, after 2-3 weeks, that people were complaining about, oh yeah, but this is slow, but this doesn't super responsive. So they had to tweak this, okay? So Gluware is not capturing this behavior of users. It allows them, but it allows the network engineer to deliver this quasi model that, in the case of this example, the quasi model to this, and really fine tune exactly and make sure it's delivered. This is super important because once the user complains, they're going to readjust. And they thought that one quasi engine that was working in the lab was good enough. Well, you're not going to make one change. You want to not be afraid of making change anymore because you have a way to say, okay, this is my reference config. Make sure that this is the same across all my backbone routers. In the case of this example, it was on the backbone routers.
And that's where the continuous validation comes in with the closed loop because you're going back again and saying, all right, let's double check this.
And this is something that we can talk about the use case too when we're going to talk about node state assessment, is that how can you automate understanding the state of your network and make sure that you can have, adjust your models accordingly. Okay.
I'll just add that, Gluware is coexisting with the SNMP-based monitoring systems and even maybe NetFlow or flow-based monitoring systems. So oftentimes, Gluware is coexisting with those. So we could be interworked through API, but what we're focused on is like, what does a network engineer need to do on the config side, and then on the monitoring side, but from when we say monitoring, more looking at the state assessment of the box, and that's highlighted in our next use case. Yep.
So one thing I want to add for this compare engine with importance, the reason why we're able to manipulate this configuration is because Gluware has a very fine understanding of the target CLI. So when we onboard a vendor, we're trying to capture all the aspects of the syntax and the semantic of that CLI. And I can tell you that sometimes it's extremely challenging because it's a world of inconsistency. You would think, oh yeah, you add the same way, you delete the same way, you ship the same way. Well, if any experienced person using CLI on Cisco or any other vendor, especially Cisco, it's hard. It's really hard. I mean, sometimes you can add stuff, it adds up. As soon as you make a modification of a setup item, the whole thing disappears, right? So MLS cost maps or numbered ACLs, I mean, this is the way they work. And so Gluware has this fine understanding.
Well, the piece I'll add to that is we get oftentimes asked, well, how do you keep up with the vendor and their changes, right? And so with our vendor adapter layer and has that intelligence about the CLI and semantics, we actually issue monthly updates on those packages because we're keeping up. Anything our customer highlights to us that they've discovered or we've discovered gets updated in the engine. Gluware has extensive logs of all that CLI interaction. You don't have to turn on the logging mode. Everything is logged all the time, every time you're doing interaction. That way we can capture exactly what happened. And we can understand why the device maybe didn't choke down a CLI or it didn't have the right response or whatever that is. So we take those logs, we can update the engine, we deliver it immediately to the customer. It rolls into our monthly update cycle on those vendor adapters.
But on those quick semantic problems that they might bump into, the customer is in control of that, right? He doesn't need us. They can tweak this, right? If this is, they can add, we can do it for them, but they are in control of doing that. So I've talked about the comparison. Guess what? This is not good enough. The reason why, it's because what if you want to make sure you are sending these lines of CLI to a particular version of operating system, or in the example of Cisco, you have like those big boxes that supports a lot of features, and those smaller boxes, they only support like a smaller set So there are lines of CLI that you cannot send on those boxes. So you need conditional rendering. You need to make sure that you can specify, okay, this CLI is intended for this particular version or this particular hardware or this particular SKU. Even you could do that. Or if you have this particular module in it, etc. You can do that. But this is not good enough because maybe the CLI, you would like to make it dynamic. You might like the user to just put some stuff in it. So you want user interaction. So this is why we have in the Gluware rendering engine, you have a way to have this user interaction, ask them, okay, what is the value of the shaper you want for this course model, etc. So you can invite the user and interact with the user in order to create that dynamic CLI. So what if some of the values that you would want to put in the CLI is coming from another source of truth, and you want to make a REST call to just go get whatever shaper value that is somewhere, and you just want to have this dynamic in the CLI. You can do this within Gluware. You can do more later. I'll explain this later. You can even be more dynamic. Guess what? This is not good enough. This is not good enough because then on the user interaction is one thing, but maybe you already have some items in the config that you would want to reuse. The perfect example is network and mission control in iOS, where the configuration, the snippet of configuration just for 802.1x requires to know what's the current VLAN assignment on the switch port. And usually when you deploy NAC, all the switch ports are already deployed. So you need to come up with this snippets of CLI that is specific for each switch port, and each switch port is going to be different. So you would want this, you would want an engine that's going to help you with that. We have the Gluware discovery engine that's going to parse this existing CLI and make that data accessible to you, okay? So that you can use that data for multiple things, such as putting this in the CLI. And this discovery engine was getting things from the running config. What if you want this from the state of the box, from a show command? So this is what the discovery engine is going to do, is allow you to define, oh, I want to grab this particular, MTU value from a show interface and be able to put this into your dynamic CLI. So all that discovery data, this is the extra arrow that goes to the discovery engine. The goal is that you have ways to just literally put that discovery data into your CLI, and this is allow you to just do also conditional rendering. So I want to switch to. Do you have any questions? I'm going to switch to showing this to you in action.
So as Wally's switching over, we like to say, we're intelligent network automation, and what does that mean? What Olivier just said was there is a whole lot of complicated functions and actions that you have to do to automate complex tasks. And we've built a platform flexible enough to go into the largest of the enterprise, understand their use case, and show them how they can automate that for them, and it's already available now. There's no going off and writing of a script or going off and building something. Everything you just said is already capable right within the product to get going quickly. Now, when we automate, we're not generally jumping right to blasting, doing config. We're inventory, audit, drift. We progress to it. But what you're seeing here is the real intelligence and power behind complex automation.
I got to assume that there's an onboarding process.
There is an onboarding process,
you're
but
model certain policies.
Right, and what you're going to see is something very exciting here. So that's a great transition.
Exciting, cool.
How do I onboard?
Yeah, yes, that's pretty critical. I have one node here, and this node has quality of service model. Okay, this is something that I've shown before, but I want to show this in detail so that you understand how the delivery mechanism works with Gluware. Also, it's a way for me to highlight that a little bit of the construct that we're using. So in black, you have the node, and the assembly that you see in yellow is basically the container of all the network functions that you would like delivered to the box. Okay, it can be your globals, your syslog, your AAA stuff, your NTP, and it could be quality of service, it could be security, it could be as small as ACLs. Something that is not a network function, you decide. Okay? If you want to group this by network function, then you have the way to do so. And in red here, this is my gross function. It allows me to have interaction with the user or not. But most importantly, you're going to see that in this particular box here, this is what network engineers are comfortable with, right? CLI. So literally, if you know how to copy paste, then literally you can put whatever CLI here, and the engine will understand what it is. Okay. So I have like a very small config, of course, with the policy map, class maps, my interfaces. So I'm going to show you. A change that I'm going to make on a box. So let me switch to that. I get a very small change I want to make, right? I'm just going to make that change here. Let me grab this, put this in my clipboard. And let me switch to my node. Here it is. And I'm going to make that change to that box. Okay? Now I'm going to ask the engine, what are you about to do on this box with its current state? So here I can preview. And what I want to preview, I want to do a connected preview. So nothing's going to happen. Nothing's going to happen. The engine will tell me what it is about to do. I'm switching to logs here so that you guys see it's humming. The goal is to be able to report what is about to happen when you're going to execute this. Nothing's going to happen. Right now,
so it's a print preview of the CLI commands that are going to get rendered on that box. It's going to say, based on the current state, this is what I'm going to need to do to get it into the desired state. So
I'm sorry. So I've put this like in bigger, because if you look at the change here, you can see that this is the way that the CCIE would do that change. What is it? Is it like, removing what's not supposed to be there, crawling the structure, not killing the whole object? The goal is to only issue what's necessary. So I just put like a slides together where this is, the conventional approach where when you automate, because this is complex, usually it's very easy, very tempting to just take the whole object, kill it, and try to reapply the cause one. Well, sometimes this is dangerous to do so. Because let's say that this is an ACL that controls your routing, and you're filtering the routes out, and there are certain routes you do not want to send out, or that this is an ACL filtering traffic you don't want to, you don't want traffic to go through that ACL. You're not going to destroy that ACL and rebuild it from scratch, because it's going to break your routing, or it's going to poke a hole through your security. Okay, yes, for 5 seconds, but 5 seconds it's already too big. So our approach is trying to issue, and this is exactly what you have in the log of Gluware. We try to do this the way that a network engineer would do this, right? So only cleaning up what's necessary, adding what's necessary, and most importantly, because if you look at here, hopefully this is not too small, but obviously the engine says, well, you've got old class maps here that should be killed. And so you can see that it is you, no. Okay. So now that you're familiar with like those different constructs, I'm going to show you how I got there. So sure, I can do it the manual way, where I build all those blocks one by one. Those are my class maps and policy map, etc. But like you were asking, how do I onboard? I don't want to do this. I don't want to do this. I have one node that is my reference node. Is there a way that I can onboard all these different network features and then use those onboarded features as my reference model and start spreading this across other nodes? So I'm going to show this to you now. It's called Intelligent Model Discovery, IMD. Let me switch to another instance of Gluware where I have removed like absolutely everything. And so this particular box here, let me show you. This particular box here, there's nothing. It's the only thing that's defined for this box. is my IP, my username and my password. And you can see that right now, there's absolutely no model associated to it. So I'm going to right-click on this one here, and I'm going to launch this particular workflow here. And I'm going to ask the engine, OK, well, go on it and tell me what's running on it. So what's running on it from a network function standpoint. And you have ways to define those network functions. Okay? We're trying to feed the most common ones, quads, etc. But the goal is that you're in control of what you want to discover. And so once this workflow will be done, it will expose me using the Gluware constructs all the different snippets relevant per network feature. And I will choose what I want. So it's almost done here. So what Gluware found, it found NTP working on that box, quaz, SNMP, syslog, and a username. Again, this is because this is what I have in my, what we call a binder. And the binder is the list of features that you want it to discover. And you can see all this different, I mean, quaz is pretty interesting. You have all these ACLs, you have all these class maps, all those policy maps, and you have ways to tweak and say, I want this, I don't want this. But this is a way to onboard, okay? So let's assume I want everything. It's going to say, okay, you do want everything. I said, yes, I want absolutely everything for this box. Let me close this. And if I go back to my node map now, you can see that now my box got all these different, construct builds with all those onboarded CLI that were on those. Were in the box, all the class map stuff for quads, etc. So I mentioned the assembly before, the yellow box, right? This is the one that is right now activating those 5 features. They're currently pointing at those 5 features. I can now use this assembly and assign this to all my other nodes and say, now this is your reference syslog, NTP, quaz, and the 2 other, can't remember, the 2 other features that's IMD, Intelligent Model Discovery found.
So to what extent can we model the network itself in the sense of, so now I have this reference architecture that says this is what the configuration should look like, this is what a BGP or OSPF configuration should look like?
Yes.
But these are the adjacencies I have. Looks like the adjacency is not there. Let me check the OSPF adjacency and check that specifically. That kind of goes back to the operational thing I said before, I know. But that's nevertheless
That's a perfect question, and it's use case number 2.
Did you say it's a perfect question?
Yeah.
Tom, can you jot that?
Yeah.
That's a perfect question.
Because it's use case number 2. It's what I'm going to show.
I think that's the cool part right now. Config management this is really cool. I love this stuff because I used to be a regular engineer in the field, wearing a fleece in the cold aisle of the data center, and I'm done with that, thankfully. But then going beyond just the config management to modeling the network and then being able to do some kind of continuous validation on the operation of the network, not just config creep or whatever you want to call it, ACL creep. That's really compelling to folks out there hacking at CLIs right now.
Yeah, it's the difference between configuration state and operational state.
Yeah.
Because while we hope that the operational state that we want, that we desire, happens through the configuration, networks are dynamic, and that's not always the case.
Oh, it's a much harder problem to solve.
Right.
But I think that's where we're going. And you mentioned intent-based earlier.
That's right.
You used that term out there. I think this is my opinion, there's a lot of vendors that I think use the term and they're not doing intent-based networking, but I've always thought you guys are because of this continuous validation with the reference architecture and everything, and I think that's really where we're going.
I mean, when you're making a change, you want to make sure that you control that change. So what I've shown so far is that we'll make sure that the change is going to occur and occur exactly the way you want it. But has that broke something? I mean, can you really make that change? is more a question. So it's beyond the configuration aspect, right? This is state is very important. Sometimes you want to perform an OS upgrade because you want to solve a bug. You don't know that this particular version within the features that you're using in your box is going to break your box. You don't know that. So. But you have SSH, everything's working. You don't know that it's truly broken.
So just to tie in to your feedback and to kind of transition to the second use case is, and then maybe switch me over for the quick introduction, which is what Olivier showed you is that first step of automation, which is getting to a certain point of config standardization. And oftentimes these organizations are like looking at Banner and NTP and syslog and things that should be defined as a central policy and should be pretty consistent. Now, what you're able to do beyond that step one, which you just showed you of onboarding, is then go in and do additional conditionals, like maybe I have a regional NTP server, and so I can tie that level in. You start kind of building out your the complexity of what you're automating.
Yeah.
When you're getting into more complex constructs, we came from the space of SD-WAN, which is underlays and overlays and a lot of complex relationships. The Gluware engine is actually very capable of even handling those things. One thing we're working in beta with now is EVPN. So when you're approaching something that is you have to have relationships between devices. Mm-hmm. For Gluware, you have to layer on some intelligence on top of those underlying building blocks of the modules and what CLI am I generating, and that comes in workflows. And so workflows for us isn't a focus today in this session just due to time. We had to drop out a couple things. Unfortunately, that one dropped. But with layering workflows, we can bring in the business logic layer, business level intent. We can bring in the programmatic or design or network objective layer, which is bringing in things like routing relationships or overlays or underlays. When I mentioned workflows, our whole series of first workflows Gluware ever produced were all related to building a relationship of that underlay, overlay, and things that you see in modern SD-WAN networks and things like that. So with that, we'll conclude use case number 1 and move on to use case number 2.
I have a quick question
sure.
From Twitter. Bruno was asking, can Gluware automate all the features of the vendors that you've onboarded so far, or have you guys run into any limitations?
Well,
Yeah.
if it's in the it's a good question. If can you see it in the show run? Okay. If it's in the show run, then the answer is yes.
Yeah. So ultimately, as long as it's within the operating system support, Gluware facilitates any of the commands from a config standpoint as well as from a show standpoint, and same when it comes to API. It's basically if the API call is there, the API call is working. There was a quote, I love to bring it out, which is, automation can't fix bad architecture, automation can't fix, let's say, bad vendor implementation or problem. So we're a layer on top of what the vendor can do. If the vendor can do it, we can automate it, is basically what it comes down to.
Excuse me, do you apply the configurations transactionally? For example, if it fails on one box, you don't apply it on the other box?
Yeah, that's a great question. And as you know, some vendors are transaction oriented in terms of that CLI interaction. Other vendors, their implementations are not transaction oriented. So Olivier, maybe you can comment on how we wrap intelligence around.
Yeah, so for instance, OS upgrade is a very good example. You start like a campaign and you're targeting, let's be ambitious, like 1,000 nodes that you want to do overnight. And some boxes start to fail. They don't come back, whatever the reason. You did your best in the lab, you validated that image, you're sending it, and you start having problems, or we're going to talk about node state assessment. The assessment will say, no, bad update. So you can configure the amount of accepted failures that you want, and if you're past that threshold, it kills the campaign. So it won't touch the other boxes, something like that. Because you don't want to break 1,000 bucks, obviously.